NVIDIA CEO Jensen Huang said, every future supercomputer will be GPU based, and every NVIDIA scientific supercomputer will be hybrid. But how do you actually make a delicate quantum processor work seamlessly with a massive GPU supercomputer? We are here to reveal the answer. In the next few minutes, this video will explain the NVQLink architecture, the specialized interconnect that delivers the sub 4.0 microsecond speed and deterministic control required for quantum stability. By the end of this video, you will gain a clear, deep understanding of the exact technology that is now defining the infrastructure standard for the entire quantum computing industry. So let us get started. So there is a foundational platform shift in high performance computing, which is the NVIDIA NVQLink. In this new era, quantum processing units, QPUs, and graphics processing units, GPUs, must work together seamlessly. NVQLink is the technology that makes this physical vision a practical, engineered reality. Now, to appreciate the solution, we must first understand the problem, which we call the quantum classical integration challenge. Quantum processors are extremely delicate. They require continuous real-time control algorithms just for calibration and essential error correction. Now, here is the critical challenge. These control loops must operate within microsecond windows. If the classical supercomputer is too slow in sending corrections back, the quantum state falls apart, a process called decoherence. If that happens, the entire computation is useless. Traditional interconnects are simply not fast or consistent enough to prevent this. The definitive answer to this problem is NVQ Link. NVQ Link is a specialized architecture engineered to create a real-time hub. It tightly couples the classical GPU supercomputer with the quantum processor, ensuring the necessary speed and reliability. Now, this architecture delivers 400 gigabits per second throughput and a critical sub 4.0 microsecond latency. This transforms the theoretical concept of quantum error correction into practical real-time operation. Now let's review the shortcomings of traditional technology for this task. The reasons why traditional interconnects fail. So standard PCI Express or PCIe suffers from a latency, which is the communication delay that is in the tens of microseconds. Now this is too slow and critically non-deterministic, meaning the timing isn't consistent enough for quantum control feedback loops. Then InfiniBand is fast, but it is optimized for internode networking, connecting separate server racks. It's not built for the intra-node memory sharing environment required for real-time control of a single quantum system. Standard NVL link gap. Even NVIDIA's own standard NVL link, which is excellent for GPU to GPU communication, lacks the specialized protocols and APIs needed for the deterministic low latency handshake with heterogeneous QPU controlled hardware. NVQ Link is purpose built for quantum. It specifically bridges the unique performance gap between high throughput parallel GPU compute and ultra low latency deterministic QPU control signaling. NVQ Link is designed to work with all types of quantum processors, ensuring it remains relevant no matter which technology becomes dominant. NVIDIA has formed a large group with 17 quantum processor builders, 5 controller builders, and 9 US national labs to guide its development. Open approach helps NVIDIA's computing infrastructure stay central to the quantum computing field. The specifications of NVQ Link are strictly dictated by the rigorous physical demands of quantum error correction, which stands for QEC, and the qubits limited coherence times. Now look at these numbers: 400 GB per second throughput. This refers to the speed at which data can be continuously sent between the GPU and the quantum processor. It's like a very wide and very fast highway for information specifically designed for the constant flow of data needed for quantum error correction. Then less than 4 microsecond latency. This means the time it takes for a signal to go from the FPGA, which is a type of control hardware, to the GPU and back to the FPGA is less than 4 millionth of a second. Now this is extremely fast. Its predictable response time is crucial because quantum states are very fragile and need immediate corrections to prevent errors. And look at the third number on your screen, 40 pflops performance. This indicates the immense processing power of the coupled GPU system, specifically for AI calculations. Now, this power is used to quickly decode complex quantum error correction data. Now, these technical specifications are not arbitrary. They are precisely chosen to meet the strict physical requirements for correcting errors in quantum computing and maintaining the stability of qubits. Now, qubits are the basic units of quantum information. Now, look at this table, and you can pause your video to take a clearer look at this table. This clearly demonstrates how NVQLink is unique in the market. The one thing I would highlight for the viewers is notice the latency column. NVQLink is the only solution that provides the necessary less than 4 microsecond deterministic latency for real-time QEC. Every other option, from PCIe to InfiniBand, is either too slow, non-deterministic, or simply not built for the intranode QPU to GPU tight coupling. NVQLink is not just a faster connection, it's a design standard essential for utility scale quantum computing. Now, NVQLink is the key to enabling what we call as fault tolerant quantum computing, or FTQC, which is the ultimate goal: reliable quantum computers. It accomplishes this through three essential capabilities. The first one is accelerated QEC decoding. This means the GPU quickly processes complicated information to fix errors in quantum bits, noisy physical qubits, and turn them into stable, reliable quantum bits, which is the logical qubits. The second one is dynamic calibration. This refers to adjusting the quantum processor in real time to ensure it works as accurately as possible, which helps reduce the amount of time it's not working. And the third one is logical orchestration, which is a unified system that smoothly manages and runs hybrid quantum classical computing tasks, especially those that require fault-tolerant quantum computing workflows. The comprehensive support NVQLink offers of various quantum computing technologies is highlighted how NVQLink is compatible with different types of quantum modalities, such as superconducting, neural atom, photonic, and ion trap systems, ensuring NVIDIA's infrastructure remains a key component in the evolving quantum computing landscape. So, supercomputing, neutral atom, photonic ion trap. Now, these are different types of quantum computing technologies, each using a different physical method to create and manipulate qubits, which are the quantum bits. Superconducting uses supercoupled circuits to create qubits. Examples include Rigetti IQM and Alice and Bob. Neutral atom uses individual neutral atoms trapped by lasers to create qubits. Examples include Pascal, Quera, and atom computing. And photonic uses photons, which are particles of light, as qubits. An example is Orca computing. Then ion trap uses charged atoms, which are ions, held in place by electromagnetic fields to create qubits. Examples include IonQ and Quantinium. Now, NVQ links universal compatibility. It's universally compatible. This means that NVQ link is designed to work with all these different types of quantum technologies. This ensures that NVIDIA's infrastructure remains a central and important part of the quantum computing field, regardless of which specific qubit technology becomes the most popular. Now, that's a very strategic move that NVIDIA has made. Now, this is not just a roadmap, it's a proven technology. They have successfully integrated NVQ Link with production hardware from partners like Quantum Machines. Now, in these demonstrations, they have executed a full real-time control cycle from measurement to correction in a single unified executable at microsecond latency. The qubits were measured, the syndrome data, the error information was transferred from instantly to the GPU. The GPU performed the intense classical decoding computation. The correction results were returned in real time. This is the proof point that hybrid quantum classical feedback for scalable FTQC can run reliably and deterministically. The hardware excellence of NVQ Link is fully realized through NVIDIA's software platform, which is the NVIDIA CUDA-Q. This is their unified open source programming model for hybrid quantum classical computers. CUDA-Q provides three major benefits for developers. The first one is unified programming, which is a single system to seamlessly integrate QPUs, GPUs, and CPUs. The second one is rapid development. You can develop your algorithms and simulations and port them directly to a physical QPU. And the third one is guaranteed performance. NVQLink is underlying fabric that ensures the required ultra-fast execution, speed, and determinism that quantum demands. And NVIDIA is already deploying this vision at massive scale. The Argonne National Lab is building two NVQ-Link ready supercomputers, the Solstice and Equinox. Now, these supercomputers will feature a very large number of powerful NVIDIA GPUs, up to 100,000 Blackwell GPUs. The GPUs stand for the graphic processing units. And this means that these deployments will quickly test and confirm the effectiveness of NVQ Link on a massive scale. The information gathered from these deployments will be essential for improving the design of NVQ Link. Now, these deployments confirm that a huge amount of classical computing power is being dedicated to support the future needs of quantum computing. Their strategic vision is perfectly summarized by CEO Jensen Huang, where he said, every future supercomputer will be a GPU based, and every NVIDIA GPU scientific supercomputer will be hybrid, tightly coupled with quantum processors. NVQ Link is the operational mechanism for this unified vision, positioning NVIDIA as the infrastructure linchpin for the quantum GPU supercomputing era. Their strategy is focused on infrastructure dominance while avoiding the high risk development of proprietary QPU hardware. What have they done? They have launched an open standard. NVQ Link establishes the first high performance open standard for quantum classical integration. By offering the indispensable interconnect, they encourage 17 QPU builders to align with the NVIDIA ecosystem to access major research and HPC markets, meaning there is an ecosystem lock-in. Future-proof your roadmap. Their commitment continues with future plans like the Rubin Ultra system in 2027, featuring NVLink 576, connecting 576 GPUs. So to conclude, NVQ Link represents the foundational platform shift that the world has been waiting for. It resolves the most pressing architectural challenge in quantum computing, the deterministic high-speed integration of quantum and classical supercomputers. The technology is accelerating the timeline for utility-scale FTQC, standardizing the classical control tower, and enabling real-time QEC and stable logical qubits. NVQ Link is truly the Rosetta Stone for the hybrid computing era. With that, we come to the end of the show. Thank you so much for watching. If you learned anything from this video, please like, share, and subscribe to AI with Arun show. And we sincerely hope that you can join us as a member. All you have to do is click at the description and you will see the way to join to become a member at the bottom of the description. Thank you so much for watching.